At 11 o'clock in the morning on January 17, 1955, a signalman on a submarine moored at the Electric Boat Company's pier in Groton, Connecticut, blinked a message to the escort tug Skylark waiting in the Thames River. 4 words: underway on nuclear power. Those 4 words ended one era of naval warfare and began another. Not gradually, not over years of slow transition. In a single morning, on a single ship, with a single message, the submarine changed from a weapon that could dive to a weapon that could truly disappear. The difference between those two things is the difference between a tactical instrument and a strategic one, and the implications of that difference are still playing out in the waters around Iran, in the Pacific, and in every ocean where an American submarine is operating right now. The USS Nautilus SSN-571 was not the first submarine. It was not even the most capable submarine of its generation in terms of weapons or sensors. What it was is the most consequential warship built in the 20th century. More consequential than the Iowa-class battleships with their 16-inch guns. More consequential than the Essex-class carriers with their air wings. More consequential than any surface combatant in any Navy's inventory before or since. Because Nautilus did not just add a new capability to the submarine, it removed the submarine's fundamental vulnerability, the one weakness that every anti-submarine warfare doctrine since the First World War had been built around exploiting. It removed the submarine's need to surface. Before Nautilus, a submarine was a surface ship that could dive. Its diesel engines needed air to run. They consumed oxygen. They produced exhaust. They required the boat to come to the surface or near the surface regularly, either to run the engines directly or to use a snorkel to ventilate the engine compartment. The German U-boats of the Second World War, the most operationally successful submarines in history up to that point, typically submerged for 12 to 48 hours before the need to recharge batteries or renew the air compelled them to surface. A submarine that must surface is a submarine that can be found. Allied anti-submarine warfare in the Second World War was built entirely around this fact. Find the submarine when it surfaces, kill it then. The convoy escort groups, the long-range patrol aircraft, the hunter-killer task forces built around escort carriers, all of them were optimized for finding submarines during their surface transits and their snorkel operations. Nautilus made all of that obsolete, not improved. Obsolete. A nuclear submarine does not surface. Its reactor consumes no oxygen. It produces no exhaust that can be detected by infrared sensors. It does not need to ventilate. The only thing that forces a nuclear submarine to the surface is the need to feed its crew and replace consumable supplies. And the nuclear submarine's ability to remain submerged for weeks at a time, traveling at speeds that diesel submarines could maintain only briefly on their electric batteries, meant that anti-submarine warfare doctrines that had been hard-won through 2 world wars of brutally costly experience were suddenly useless. The Naval History and Heritage Command study conducted in 1956, examining the effects of Nautilus on contemporary anti-submarine warfare practices, was unambiguous in its conclusion. Anti-submarine practices as used during World War II were ineffective against a submarine which did not need to surface, could dive deeper, and could clear a search area in record time. The study did not say anti-submarine warfare needed to be improved. It said the entire knowledge base that had been accumulated through 2 world wars was ineffective. Starting over was not optional. It was the only path forward for any Navy that wanted to maintain any meaningful ability to detect and counter nuclear submarines. To understand how revolutionary this was, you have to understand the specifications of the Nautilus against the submarines it replaced. A diesel-electric submarine of 1954, the best conventional submarine technology available at the time, could make perhaps 8 to 10 knots submerged on its electric batteries and could sustain that speed for only a few hours before the batteries were depleted. At slower speeds, perhaps 3 to 4 knots, it might manage 12 to 24 hours submerged before the battery state required either snorkeling to run the diesel generators or surfacing entirely. Its practical combat endurance on patrol was measured in days before it needed to surface for an extended period. Nautilus, on its first shakedown cruise in May 1955, traveled 1,381 miles from New London to San Juan, Puerto Rico in 89.8 hours, submerged the entire way. That was the longest submerged cruise by any submarine in history at that point, by a factor of 10. It maintained a sustained submerged speed of approximately 16 knots for the entire 90-hour transit, a speed that no diesel submarine could maintain submerged for more than a fraction of that time. And after arriving in San Juan, Nautilus did not need to stop to refuel its reactor. It had used an insignificant fraction of the fuel in its S2W pressurized water reactor, a reactor that would not need its first fuel core replacement for over 2 years and 60,000 nautical miles of operation. The man who made all of this possible is one of the most important and least celebrated figures in American military history. Captain, later Admiral, Hyman George Rickover, whose title Father of the Nuclear Navy is accurate but inadequate. Rickover was not simply an advocate for nuclear propulsion. He was the engineer, the administrator, the bureaucratic warrior, and the demanding perfectionist who built the entire institutional framework, the physical infrastructure, the training programs, the safety standards, and the quality control systems that made nuclear naval propulsion not just theoretically possible, but operationally reliable. Rickover's story begins in the late 1940s, when the Navy's leadership was deeply skeptical of nuclear propulsion for submarines. The technology was new. The engineering challenges were formidable. The safety risks of putting a nuclear reactor in a vessel that operated underwater were genuinely concerning. The Bureau of Ships had other priorities. The institutional resistance to a fundamentally new approach to submarine propulsion was substantial and persistent. Rickover overcame it through a combination of technical brilliance, relentless advocacy, bureaucratic maneuvering, and a willingness to make powerful enemies in pursuit of a goal he was convinced was essential to American naval power. His approach to the Naval Reactors Branch of the Atomic Energy Commission, which he convinced to give him joint authority over nuclear propulsion development, allowed him to control both the military and civilian sides of the program simultaneously. He used that control to impose standards that the existing naval bureaucracy would never have accepted from a program managed through conventional channels. Every detail of the reactor design, every material specification, every manufacturing process, every test procedure, every operator training requirement went through Rickover personally. He interviewed every officer candidate for nuclear submarine service himself, personally, in sessions that became legendary for their psychological intensity and unpredictability. He was looking not just for technical competence, but for the specific combination of intellectual rigor, personal honesty, and tolerance for ambiguity under pressure that he believed nuclear submarine operations required. The result was a safety and reliability record that was and remains extraordinary. The United States Navy has operated nuclear-powered submarines and surface ships since 1955. As of today, that is more than 70 years of continuous nuclear naval operations. In all of that time, with all of those vessels, in all of the operating conditions from Arctic under ice to tropical shallow water, no American nuclear-powered naval vessel has ever suffered a reactor accident that caused a radiation release affecting the public or resulted in deaths attributable to nuclear causes. That record is not an accident. It is the direct product of the standards, the training programs, the safety culture, and the institutional framework that Rickover built, and that the Naval Nuclear Propulsion Program has maintained for 7 decades. The Soviet Union, which launched its first nuclear submarine program just months after Nautilus, following a parallel development that had begun in June 1954, did not achieve the same safety record. Soviet nuclear submarines suffered a series of reactor accidents, fires, and losses that resulted in crew deaths and, in some cases, releases of radioactive material. The K-19, the first Soviet ballistic missile submarine, suffered a catastrophic coolant loss accident in 1961 that killed 8 crew members and left the entire crew exposed to dangerous radiation levels. The K-278 Komsomolets, a Soviet submarine lost in the Norwegian Sea in 1989, sank with nuclear-tipped torpedoes still aboard. The K-141 Kursk exploded and sank in the Barents Sea in 2000, killing all 118 men aboard in an accident that began with a torpedo fuel leak rather than a reactor problem, but that illustrated the consequences of the Soviet naval nuclear program's different approach to safety culture and maintenance standards. The American nuclear submarine force has never lost a submarine to a reactor accident. It has lost 2 submarines, USS Thresher in 1963 and USS Scorpion in 1968, both to non-nuclear causes, flooding and unknown cause, respectively. The reactor safety record that Rickover built has held for 70 years. That record is the foundation on which American nuclear submarine operations depend. The Nautilus's combat implications became clear almost immediately after commissioning. In 1955 and 1956, exercises with hunter-killer groups off Bermuda and in Narragansett Bay demonstrated that contemporary anti-submarine tactics were essentially helpless against a submarine operating at Nautilus's speed and depth without needing to surface. The hunter-killer groups could not maintain contact. The patrol aircraft that had been the primary submarine hunters of the Second World War were useless because there was nothing to hunt at the surface. The acoustic sensors that had detected snorkeling submarines had to be redesigned for a threat that was quieter, faster, and deeper than anything they had been calibrated for. The implications extended far beyond anti-submarine warfare. The nuclear submarine's ability to remain submerged indefinitely, combined with the nuclear ballistic missile technology that was being developed simultaneously, created an entirely new category of strategic weapon. The Fleet Ballistic Missile Submarine, the SSBN, carrying nuclear-armed intercontinental ballistic missiles and operating at depths and in locations that made it essentially immune to preemptive attack, became the most survivable element of the American nuclear deterrent triad. An adversary who could destroy all American land-based missiles and all American strategic bombers in a first strike could not destroy the submarines. The submarines could not be found. They could not be targeted. They could not be preempted. And each one carried enough nuclear weapons to destroy dozens of cities. The George Washington class, the first American ballistic missile submarine, entered service in 1960 carrying 16 Polaris A-1 missiles with a range of about 1,200 miles. Direct descendants of this concept are still at sea today in the form of the Ohio-class SSBN, the most powerful strategic weapon ever deployed by any nation, carrying up to 24 Trident 2D5 missiles with a range exceeding 7,000 miles, each missile capable of carrying multiple independently targetable warheads with nuclear yields orders of magnitude greater than the bombs that ended the Second World War. There are 14 Ohio-class SSBNs in the American inventory. On any given day, approximately 8 of them are at sea. Their locations are known only to the most senior levels of American military command. They represent the most credible guarantee of American nuclear deterrence that exists. And they exist because Nautilus proved in 1955 that a nuclear submarine could operate indefinitely at sea without surfacing. The attack submarine lineage that descended from Nautilus followed a separate but equally consequential evolutionary path. Where the SSBN's strategic value is in its invulnerability and its ability to strike anywhere on Earth with nuclear weapons, the fast attack submarine's value is in its ability to hunt, to deny sea control to adversaries, and to project power in ways that surface ships cannot match in contested environments. The Skipjack class, which combined Nautilus's nuclear propulsion with the teardrop hull form developed from studies of the German Type 21 U-boat, produced the basic configuration that all subsequent American attack submarines have followed. The Permit class, the Sturgeon class, the Los Angeles class, the Seawolf class, and the Virginia class that is entering service today are all direct evolutionary descendants of the lessons learned from operating Nautilus. The teardrop hull maximizes hydrodynamic efficiency for underwater speed. The pressure hull design optimizes for deep operating depth. The reactor plant provides the power for both sustained high speed and the quiet slow speed operations that minimize acoustic signature. The Virginia class, the current frontline American attack submarine, represents 7 decades of learning from Nautilus's operational experience. It is quieter than any submarine that preceded it, achieving acoustic signatures that American intelligence assesses to be below the ambient ocean noise level in many conditions, meaning that passive sonar cannot detect it at tactically relevant ranges because it is quieter than the ocean itself. It carries 37 Tomahawk cruise missiles, in addition to Mark 48, AD-cap heavyweight torpedoes, and can conduct special operations, mine warfare, intelligence collection, and anti-submarine warfare missions in addition to its primary strike role. The Block 5 variant, currently entering service, adds the Virginia Payload Module, inserting an additional section into the hull that carries 28 additional Tomahawk missiles, bringing the total Tomahawk capacity to 65. A single submarine. 65 Tomahawks. Undetectable, operating anywhere on Earth where there is sufficient water depth. The connection between Nautilus and the operations of 2025 and 2026 is direct and traceable through every development in between. The Ohio-class SSGN that fired 24 Tomahawk cruise missiles at Isfahan during Operation Midnight Hammer in June 2025 was a submarine whose basic reactor and hull design philosophy descended from Rickover's work on Nautilus. The Virginia-class boat that fired a Mark 48 torpedo into the Iris Dena in Indian Ocean waters in early 2026, killing the Iranian frigate 1,500 miles from the battlefield, was the direct inheritor of the concept that Nautilus proved in 1955. A submarine that never surfaces, that cannot be found, that can strike anywhere within its weapons range without warning, is not a tactical asset. It is a strategic one, and its existence changes the calculations of every adversary that contemplates conflict with the United States. Rickover died in 1986. He was 86 years old and had served on active duty for 63 years, a record that may never be equaled. He had supervised the construction of over 200 nuclear warships. He had personally interviewed every officer candidate for nuclear submarine duty for 30 years. He had built the institutional framework for the safest nuclear operations program in the world and had maintained that safety record through the administrations of 7 presidents. He had made countless enemies, had been repeatedly passed over for promotion until political intervention forced the Navy to promote him, and had been twice forced into retirement before his work was complete, with political intervention forcing his retention each time. What he left behind is not just a technology or a fleet. It is a culture, a set of standards, a philosophy of engineering excellence and personal accountability, a framework for operating extraordinarily complex and dangerous systems in hostile environments without compromise and without shortcuts. The nuclear navy that exists today, with its unbroken safety record and its globally dominant capability, is Rickover's legacy, as much as it is the legacy of any specific design or any specific weapon. The submarine that changed everything is a museum ship now, moored at Groton, Connecticut, at the Submarine Force Library and Museum. You can walk through it. You can see the reactor compartment where the S-2W pressurized water reactor operated for 25 years. You can stand in the control room where Commander Eugene Wilkinson sent those 4 words to the escort, tug, on the morning of January 17, 1955. Underway on nuclear power. Those 4 words are the foundation of everything that has followed. Every nuclear submarine that has ever operated under any flag, every SSBN that has maintained nuclear deterrence for 7 decades, every attack submarine that has hunted adversary fleets in silence, every Tomahawk that has been fired from a submarine toward a target hundreds of miles away, every torpedo that has been fired from a depth that no surface ship could detect, every operation in which American submarines positioned themselves for months in advance in complete silence, building the intelligence picture that made the kill chain work. Underway on nuclear power. 4 words. 1 morning, 1 submarine. The most important moment in naval history since the introduction of steam propulsion. And nobody talks about it. If you want to understand how the nuclear submarine force that Nautilus made possible became the decisive instrument of American sea power in the conflicts of 2025 and 2026, how the Virginia class is being designed to maintain that dominance against China's expanding submarine fleet, and what the future of undersea warfare looks like as artificial intelligence and autonomous systems begin to transform a domain that has not fundamentally changed since Rickover's time, subscribe to Navy Power Decoded. Every video goes deeper than the headlines. USS Nautilus SSN-571, underway on nuclear power, January 17, 1955. Everything that followed was the consequence of that morning. The men who built Nautilus are gone. The men who first sailed her are in their 90s, or they are gone. Commander Eugene Wilkinson, who sent those 4 words and who set the standards for what a nuclear submarine commanding officer should be, died in 2013 at the age of 91. Admiral Rickover died in 1986. The engineers at Westinghouse and Electric Boat who built the S-2W reactor and the hull that carried it are part of history. What they built outlasted them by decades and will outlast everyone reading this analysis as well. The nuclear submarine is not going away. China is building them. Russia still operates them despite the losses and the accidents and the economic constraints. Britain and France maintain their independent deterrence at sea aboard SSBNs that exist because Nautilus proved the concept worked. Australia is acquiring them through the AUKUS partnership, a trilateral agreement between the United States, the United Kingdom, and Australia that was specifically designed to transfer nuclear submarine technology and operational expertise to Australia to address the changing strategic environment in the Indo-Pacific. The decision to transfer that technology, made in September 2021, was one of the most significant strategic decisions in the history of American alliance management, and it was made possible by the 70 years of nuclear submarine operational experience and safety culture that Rickover built, starting with Nautilus. The Virginia-class boats that AUKUS will eventually transfer to Australia, and the SSN AUKUS boats that will be designed and built jointly to follow them, are Nautilus's grandchildren. They carry the same fundamental concept, nuclear propulsion for indefinite submerged endurance and unrestricted global range, that Wilkinson's signalman announced to the world on January 17, 1955. The technology is orders of magnitude more sophisticated. The weapons are incomparably more capable. The acoustic stealth is so advanced that the ocean itself provides cover. But the concept is the same. A submarine that never surfaces, a weapon that cannot be found, a strategic instrument whose very existence changes the calculations of every adversary. Nautilus is a museum now, but what it started is still very much alive, still very much at sea, and still very much changing the outcome of conflicts in ways that the world does not fully appreciate until the results are already decided. Underway on nuclear power. 4 words, 70 years. Still the most important thing ever said on a submarine.